So might I suggest you get out a piece of paper and take some notes? We are going to look at operations of functions, and I think you're going to be pleasantly surprised by how shockingly easy this is. Okay, so what's going to happen is we're going to take two functions. Like let's say we have f of x equals x minus 1, and we have g of x, which equals negative 2x plus 3. We are going to perform operations on the two functions. So, for example, we're going to have notation that looks like this. So, the notation has a couple different ways to write it. We can take the sum of the functions, which in this case would be f of x plus g of x. And we can also write that as f plus g of x. We can take their difference. All right, difference means subtraction, which means we can just take f of x and subtract the g of x function, which we can also write in one bracket like f minus g of x. Do you see how there's just two ways of writing it and they mean the exact same thing? We can take the product of functions. Product is written like this with a closed small dot. So f of x times g of x, or we can write f times g of x. Make sure that dot you're writing is like an actual closed little dot. You'll see why. And then of course we can do the quotient of functions, and that's when you have f of x divided by g of x, which can also be written as f over g of x. Okay? So that's the notation on this. So let's say over here we wanted to find the sum of these two. So to find the sum of f plus g of x, oops, I didn't mean to change that, sorry. We would really simply say x minus 1, right, plus negative 2x plus 3. They're just adding, so it's really straightforward. We're going to combine like terms. We've got x minus 2x, which is going to give us negative x. And we've got negative 1 plus 3, which is going to give us plus 2. So the answer would be negative x plus 2 is how we would find the sum of those functions. Now, always being a little trickier is our friend subtraction. So if we were looking for the difference of sum of functions here, we would say x minus 1 subtract negative 2x plus 3. If we do this, we need to make sure we subtract each term. So that means when we collect like terms, we're going to have x minus negative 2x. Well, that's the same as having x plus 2x, which is 3x. And then we've got negative 1 minus 3. Negative 1 minus 3 is negative 4. So our answer on that one would, of course, be 3x minus 4. Okay? So you really basically just need to remember that you have to subtract that whole thing. It's easy to forget to subtract the second term. So that's pretty much all there is to adding and subtracting. Now, the other piece of notation that we want to look at is when we substitute in a number. So if we substitute in a number, it's going to look something like this. Like right now, we know that if we have f of x equals x squared plus 10, let's just say. And if I tell you I want x to be 3, if I want you to substitute in x equals 3, you would write f of 3, and that 3 means that you're going to replace the x with a 3. So you would have 3 squared plus 10, which is 19. So f of 3 equals 19. We are going to take that same thing and apply it to this. So let's look at another one. Let's say we have f of x equals x plus 5, and g of x equals, I don't know, x squared plus 3x minus 10. And we are looking for the sum of functions f of x plus f plus g of 4. So what that means is we are going to add our functions together. We're going to add them together, plus we're going to replace our x's with 4. So we're going to have x plus 5. Oops, I goofed here. We're going to have x plus 5 plus x squared plus 3x minus 10. And then we're going to replace everything with 4s. So 4 plus 5 plus 4 squared plus 3 times 4 minus 10. Put that all together and we end up with 9 plus 16 plus 12 minus 10. And we get, I don't know, 28, 18, 9 plus 18, I don't know, 27. 27, okay. And that's all that notation really means. Pretty straightforward. Now, let's look at multiplication and division. So when we're looking for product, remember product means multiply or the quotient. Quotient means you are dividing. So those are also straightforward. So let's say you've got f of x equals x plus 5, and g of x equals x squared plus 9x plus 20. So what if, excuse me, what if we were looking for the product of these functions? If we were looking for the product, we would say f times g of x. And what we would do is just simply multiply those together. It would kind of be just as you'd expect. Now you're going to have to distribute here. So we're going to have x times x squared is x cubed, and x times 9x is 9x squared, and x times 20 is 20x. Now deal with your 5. 5 times x squared is 5x squared. 5 times 9x is 45x, and 5 times 20 is 100. Collect like terms, so use your x cubed. Now all your x squareds. So 9 plus 5 is 14x squared. Your x is 65x plus 100. And that's it. We're done. That's your final answer on that. If you're going to divide, if you're looking for the quotient you have to be careful with. And also, sometimes things are written like this. It'll say h of x equals f of x over g of x. And then the instructions will be find h of x. So you're going to do the same thing. You're going to say x plus 5 divided by x squared plus 9x plus 20. But you are a smart cookie, and you know that when you've got a quadratic, you need to factor. So you are going to factor this thing, and you're going to be like, oh, I see you, x plus 5 times x, oops, I can't write, plus 4. And you see that that is going to cancel. And so h of x is going to actually equal what? It's going to equal 1 over x plus 4. And that will be your answer. Okay, that's all there is to it. So just as a quick recap, we have some difference in product and quotient of functions. And then we also need to be careful that when a number is given in place of the x, that just means you're substituting it in. It would look something like this. You go ahead and you do the operation of the two functions, and then you substitute in that number. Combine like terms, simplify, and you're done. That's it. Good job. You guys are awesome.